In this lesson, we will cover questions from section 3.5, polynomials of the form ax squared plus bx plus c. Question 1. Which rectangle model best represents the two binomials being multiplied, x subtract 6 and 3x plus 1? So the best way to approach this problem is to actually draw our own rectangular model and multiply to see which one will be the correct response. So we're going to do that on the side here. We're just going to draw our own rectangular model. And keep in mind that each piece of the rectangular model, we're going to multiply the terms to decide what expression is going to be in each section. So we have x subtract 6. We had to put that along the top or the side, doesn't really matter. And then we're going to put the 3x and the 1 on the line on the side. So 3x times x gives us 3x squared. 3x times negative 6 is negative 18x. 1 times x, positive x, and 1 times negative 6 is negative 6. So all we have to do now, we don't have to combine any like terms or anything. We're just going to look to see which rectangle model best represents what we have here. And if you notice, it is going to actually be D. A is not correct because we need a negative 6, so that one is gone. B, we need a negative 6 and a positive x, so that one is eliminated. And C, it has a negative 6 and not a negative 18x, or negative x and not a negative 18x, so that one is gone. So our answer here will be D. Question 2 says factor the trinomial 2x cubed, subtract 16x squared, subtract 40x. So when we go to factor a trinomial, we're always going to check to see if we can remove the greatest common factor first. And if you notice here, we have to do that because a trinomial does not start with the x squared term. It actually starts with x cubed. So what we're going to do, we're going to remove the greatest common factor. So 2, 16, and 40, the highest we can remove for all three of those would be a positive 2. And since we need this to become an x squared, we're only going to remove one x from every term. So once we do that, we have to decide what is left. And what we do here, we divide every term by positive 2x. And when we do that, we have x squared left, a negative 8x, and a negative 20. Keep it in mind with the laws of exponents, when we divide the same base, we have to subtract the exponents that are there. Now we have our monomial, which is the greatest common factor, removed, and our trinomial that still needs to be factored. So we're going to actually just factor what is inside this bracket. And lucky for us, we have a trinomial where a is equal to 1. So since that is already 1, we're just going to take our negative 20, our c value, and try to decide what two numbers will give us a product of negative 20 and a sum of negative 8. If we do our factors for negative 20, we'll easily find out that 2 and 10 are the factors that will give us the product of negative 20 and the sum of negative 8. But now we have to decide if it's going to be a negative 2 and a negative 10. Is it just a negative 2 and a positive 10, positive 2, negative 10, or are both of them going to be positive? We need it to be a negative 8. So if we have to make this a negative 2 and add a positive 10, that will not work. So therefore, we need a negative 10 and a positive 2. All we have to do now is leave our 2x alone. That is our GCF. And we're just going to take our two factors and write them into a product of two binomials. So we're left with x subtract 10 there. So the most common error made in this question is a lot of students will leave the GCF and not write that down beside. But you have to keep in mind that when you multiply and use the distributive property, you need to get x to the exponent of 3 back. If you leave this out, you're only going to get x squared, which is not correct. The best way to verify the solution is to substitute a number in for your x on the left-hand side to decide if the right-hand side equals the same. And if it does, you have a correct solution.